In this video, we're going to look at broadcasting, which is an important concept to understand calculation using two Numpy arrays. So here is an example where we have 1, 2, 3 multiplied by 2, and we end up with 2, 4, 6. Now behind the scenes, there's a process that match up the shape of this 2 to 1, 2, 3. So first this 2 will be stretched or repeated into 2, 2, 2. So once these two operands has the same shape, then they can be multiplied in an element-wise manner. So we end up with 2, 4, 6. So previously we have seen the example of array 2 and we add 1 to that. But what's really happening is this 1, the scalar 1, is converted into an array like this and then added to 2. So we end up with this result. So this is broadcasting in a very simple nutshell. So in simple words, it's the smaller operands will repeat itself to match up with the shape of the larger operands before the element-wise operation can take place. Now let's look at the rules in a little bit more detail. So in Numpy, if we want to do by operand operation, the two dimensions are compatible when they are equal. If 1 to 3 add 1 to 3, there's no broadcasting needed, they just be added. Or one of the dimension is 1, so that this can be repeated to match up with another one. So let's look at some examples here where we have operand 1 is 2, 3. Operand 2 is 1, 3. Now, because of this one is 1, there's still a chance to do broadcasting even though they are not equal. So this 1 can be mapped up to 2 and operand 2 can be stretched into a shape of 2, 3 by repeating itself once. And this 2, 3 can then be added with operand 1, right? So we end up with a result of 2 and 3. In some situations, operand 2 can just have a shape of 3, like it's a vector with only 3 values inside it. So in that case, it can first be reshaped into 1, 3, right? So if we start with 3, we can reshape it into 1, 3, right? Just add another layer of parentheses around it. And then this 1, 3 can then be broadcasted with 2, 3, so we end up with the result of 2, 3. So this is the situation when the number of dimensions differs. But you don't need to worry about all this because this all happen behind the scenes. All this video is trying to do is to explain to you what this behavior is, so that when you do calculation, you can expect what to happen. Another important aspect I want to point out is that broadcasting can happen both ways, because what's really happening is it's doing this matching or repeating at a dimension level. So if we have operand 1, which is 2, 1, 3, operand 2 is 1, 2, 1, like none of this shape, none of this number matches at its position. But because they all have 1 in it, so this one can map up to 3, while this one can map up to 2. So at the end, we end up as the output shape of 2, 2, 3. So in this case, it happened both ways. It's not operand 1 simply mapped to operand 2, nor operand 2 match up with operand 1. It's like it happened like in each of its dimensions. Alright, let's look at some examples using random numbers. So we have A1, which is 4, 4, 1, 3. A2 is 3. So in this case, the number of dimensions doesn't match up, so the 3 will be first reshaped into 1, 1, 1, 3. And then this 1, 1, 1 can be matched up with 4, 4, 1. So at the end, we get 4, 4, 1, 3. And we can verify this. So that's 4, 4, 1, 3. And we don't need to look at the numbers because these are all random. We just need to check the shape. So in the second example, we have the same A1, but A2 is 2, 3. Now this can still be added up or multiplied together because this 2, 3, again, the number of dimension does not match up in this case. So we first reshape into 1, 1, 2, 3, and then there's a broadcasting going on between these two, right? So the 1, 1 will be matched up into 4, 4 here, and then this 1 here will match up with the 2 here. So at the end we get 4, 4, 2, 3, and that's what we get here. So hopefully you understand broadcasting better. If you want to know more, Numpy actually has a very dedicated page about it. And in fact, I get that figure from this page. Feel free to go through this in more detail, but I think what I just went through in this video is all you need. So before we end this video, I just want to point out there's a lot of functions in Numpy that just does element-wise calculation. So for example, we can do sine on this array 2. And it just calculates the sign of each of this element. So if we use a Python list, this is not possible unless we use a loop. So just do dir on NP and go through them and see what other functions are like this sign. Right, that wraps up this video.